In a committee, in the last lecture we have seen concept of fractions, right? Okay, so related to that, three questions I would like to give you, which are word problems. Okay, in a committee, two-thirds of the total members are in a committee, comma, two-thirds of the total members are female. So out of total male, one-fourth are married. Out of total male, one-fourth male, that is male members. Out of total male, one-fourth are married. So stop. If nine male members are unmarried, then find total number of members. Find total number of members in that committee. Yes, answer please. How many of you have got answer 36? Please raise your hands. Only this much. Okay, listen. Online friends. Okay, so whatever you have written the question, very simple one. In a committee, whatever may be the total number of members in that committee, we are told that two-thirds of these are female, right? So total, let the total members be X. Out of these X, two-thirds means 2/3 part of X are female, it is told. So, but it is not necessary to tell us what part of the total number of members that will be male. So these are 1/3 of X. Is it clear to all of you? Okay, before going to that, as I asked, how many of you got 36 answer? Okay, are there some who are getting answer 108? Yes, anyone? Means without because of wrong calculations only. Okay, so listen. One-third of the two-thirds of the total members are female. So, but obviously one-third are male. We are told that out of total male members, one-fourth are married. Means what? One-fourth of this part, not one-fourth of X. One-fourth of this one. So one-fourth of one-third X. That is together it is 1/12 X. Is it clear? So in terms of X, we have married men members. So these are 1/12 X. But as we are told that what is the number 9 given? 9 is for what? Those who are unmarried male members. So that is here 1/12 X. That is X/12. You can say. So X/12 male members are married. If we subtract those married male members from total male members, so what are total male members here? X/3. One-third of X, that is X/3. Is it clear? So subtracting number of male who are married from total male, we can get number of male from unmarried. So that is equated to 9. So are you getting this equation so formed? Is it clear? Okay. So because of that, we have then by solving this one, we have here 3 4s are 12, so that's why 4x in the numerator minus x is equal to 9, whatever. So we have getting answer x is directly we can get from calculations x is 36. Actually, you can do orally also without doing these equation and all. But right now, as we are going through basics, so that's why I gave you all these with the equation. Otherwise, very simple thing. We are told that 9 are male members who are unmarried, right? So that 9 are what is it? 3/4 of male members. Why? Because 1/4 are married. So 1/4 of the total male members if these are married. So 3/4 have to be unmarried. 3/4 of any number is 9. So which numbers 3/4 is 9? 12. So 12 are male members, which are 1/3 of the total because 2/3 are female. We are told that. So 2 parts out of 3 are female. So 1 part is male. So these are given. So we are getting 12. So 12 are male. So because of that, 2 parts will be female. That is 24. So 24 plus 12 that gives you 36. Instead, you can do like this also. So is it clear to all of you? Copy. Okay. Then next question I would like to give you. So directly the first year of CSAT pattern in 2011, I would like to share this screen from question paper only. So here it is, 2011 question paper. Question number 50, 50. Just a minute. Okay. So actually, you can copy this question or you can just put reference CSP 2011, question number 50. In a group of persons, 70% of the persons are male and 30% of the persons are married. If 2/7 of the males are married, what fraction of the females is single? Okay. Try to solve this one. Online friends, you are not responding. Whatever is your answer, please put in chat box. All of you can get this one. There is a chance of silly mistake also. Yes. Okay. So shall we discuss? Yes, no. Yes. So how many of you have got your answer? Please raise your hands. 1, 2, 3, 4, 5, 6. Okay. First of all, answer is option D for the first thing. So you may be shocked if it is 2/3. Okay. Means answer has to be 2/3. Some may be getting 1/3 also. So what is that 1/3? It is not single, it is married. So answer is married, that is 1/3. Okay, or otherwise, right from start of this question, let me tell you. In a group of persons, 70% of the persons are male and 30% of the persons are married. Till this. Even we have not seen the topic percentage, but you know what is the concept percentage. What is it? Anywhere when we get percent sign or percent word, we have to imagine one number, and that is 100. Assuming that total number of persons in that group be 100. Or otherwise, whatever may be the number of people in that persons in that group, maybe 100, 1,000, lakh, 10 lakh, whatever. Per 100, out of every 100, 70 are male. Is it clear? So because of that, assuming total number of persons 100, male are 70. So but of yours remaining are female, not necessary to tell us. That is how much? 30. So because of this 30% of the total persons are male, we can say 7 out of every 170 are male and 30 are female. Then next, what is it? And 30% of the persons are married. It is told that 30% of the total, 30% of the persons means out of every 100, again from the same group, out of every 100, 30 are married. So how many are male and female? Initially we don't know. Only we know that number of persons in every 100 married are how many? 30. Is it clear to all of you? Got this one? So married are, here we can write married are 30 persons. But here next sentence, if 2/7 of the males are married, 2/7 of the males are how many we are getting? 70. 70 is 2/7. 2/7 of 70. All you present here can get this one is the number 20. So 20 male are married. Is it clear? But we know that how many total persons who are married? 30. Out of 30 persons, 20 are male. So but obviously remaining are female. How many female are married in other words? 10 only. 10. So that is 10 female are married. And we are asked, what is asked here? What fraction of the females is single? In last lecture, we have seen the concept of fractions. What fraction of female? That means in the denominator, total female should be there. So total female, how many? 30. Out of 30, how many are single? Single is unmarried. Married are 10. Out of 30 female, 10 are married. So remaining are unmarried, that are single. So 20 are unmarried, that are single. That is 20 upon 30 is the required fraction. And because of that, we have fraction is 2/3. That is option D. Is it clear to all of you? Okay, in this way only we need to solve. Okay, some may get answer again 1/3, even if they think it is of unmarried or single female again. But what is that? Let me tell you that after getting 20 male are married, 20 male are married. It is not given that 20 couples, not necessarily equal number of male and female must be married. Here it is not given couples. These are married persons only. So maybe whatever number of male and number of female. Is it clear? Okay, copy it, or if it is not, please do within no time. Let the total number of persons be 100. Male are 70, female are 30. Married male are 2/7 of 70, that are 20. But the total married persons are 30. So married female are 10. So unmarried or single female are 20 out of 30. So the required fraction is 2/3. Okay, finished. Then last question that I would like to give you on fractions, which is you can see on the screen. I would like to take note of. Take down. A train has started its journey. A train has started its journey with full capacity Online friends, you can take screenshot of this one and directly try to solve. A train has started its journey with full capacity. With full capacity. Full stop. On the first station, means after departure, first station. On the first station, 1/3 of the total passengers alight, means dropped down. 1/3 of the total passengers alight, and 96 more board the train, and 96 more board the train. Full stop. On the second station, half of the new total passengers, half of the new total means on the first station 1/3 alight and 96 more board the train, came in the train. That is now total new total. So that new total is half alight, and 12 more board the train. 12 more board the train. Full stop. On reaching the next station, it was found to be 248 passengers were in the train. It was found to be 248 passengers were in the train. Full stop. How many passengers were there initially in the train? How many passengers were there initially in the train? Online friends. Online friends, are you attending the lecture? Okay, yes. Online friends, Rishikesh. Okay, actually your calculations, in the end, your answer is double of the correct answer. So what's wrong with it? You just check. It's double of the original, means required answer. Okay. So we'll discuss. All of you have gone through this question. You have remembered that a train has started its journey with full capacity initially, means at the departure initially, whatever may be the total number of passengers, that is nothing but capacity of the train, because it has started its journey with full capacity. On the first station, whatever may be the total number of passengers in the train, out of which 1/3 have alight, and in that at the same time on the same station, 96 more, means another 96 have entered in the train. Is it clear? So now here onward, then after first station, here they have traveled from first to second station. Now on the second station, whatever is the new total passenger total, so half of that alight, and again in those 12 more board the train, and then the train has reached up to the next station, that is on the third station, you may say, and it is told that there were how many passengers in the train at that time? 248. So in this process, according to the travel given, we have to proceed the same. For that, please don't go by reverse direction. Means what? In the end, we got 248, out of which 12 have board at the last only. So don't subtract those 12 and in the reverse direction. So don't do like that one. Just even if this question is asked in competitive exams, in which means this question was asked in one of the MPSC exams, in which each question had to be solved in 36 seconds only. So even though the time given is 36 seconds, then also we have to go by equation form only. So forming equation and we can solve. So we have to assume initially there were x passengers in the train. So out of x, how many alight on the first station? 1/3. So minus, because alight, minus 1/3. But 1/3 of what? 1/3 of x. Is it clear? So directly you can write here 2/3 of x are remaining there. Are you getting me? Is it clear? X were passengers, they have traveled from initial departure to first station. X, out of which 1/3 have 1/3 alight. So remaining are 2/3 of the original passengers. So 2/3 of x remaining there, plus how many boarded train at the same time? 96. So you are getting 2/3 of x plus 96. That the number represents to whom they have traveled from first station to second station. Is it clear to all of you? Okay. So these have traveled from first station to second station. Now this is the total, new total. Of this new total, how many alike we are told? Half. Half are alike. 1/2 are alike. So 1/2 alike means remaining are also 1/2 only. So I would like to write directly 1/2 of this one. Is it clear to all of you? Don't think that we have to subtract only, and that's we are not getting feeling of that one. No, it's not. So here, are you getting this? 2/3 of x plus 96 were traveling from first station to second, and out of these new total passengers, half alike. So whatever may be the total passengers, new total passengers, they have traveled, right? New total, they have traveled. Half of them alike. So this considering as 1 minus half, remaining also half. No, are you getting me? Remaining also half. So that is what we are doing. Half of new total passengers, they remain present in the train at that time. Is it clear to all of you? Yes, yes. Plus 12. So what is plus 12? On that second station, 12 more, 12 additional have entered in the train. Now these have traveled from second station to the third, that is next station, and we are told that they were counted, and this count was how much it is told? 248. So it is to be equated with 248. Is it clear? LHS of this equation is in terms of x, and RHS is the exact number given to be equated. Okay, got this one? Okay. So you just try to solve, you can get value of x, or otherwise you can directly 1 by 2 into each of these terms. So 2 get cancelled, x by 3 plus 96 by 2, that is 48. 12 has nothing to do with 1 by 2. So as it is 12 is equal to 248. Now within no time you can transpose this 48 left to the right, it will be 200 only remaining, and plus 12 when taken to the right, it will be minus. So it is 188. Is it clear? So x by 3 is 188, that is x is 3 into 188 gives you 564. Online friends, is it clear? Offline, all of you have finished this one. Okay, so in this way we have finished this topic, completed, not finished, completed, we may say, this topic, that is fractions. Then the next one of the most important topics, that is from our exam point of view, is HCF and LCM. So please give heading HCF or GCD and LCM. So in our maths, so we have seen only 3 topics. First is number system, second is mathematical operations, and third is fractions. We have not done the calendar topic, right? Or we have done it. Okay, no, just I'm asking. Okay, no problem. So we'll continue the same first of all. HCF or GCD and LCM. As I said, it is one of the most important topics from our exam point of view. So here we must know what is meaning of these HCF or GCD and LCM. Why? Because why we should know this one? UPSC will never say that find HCF and LCM of the given numbers and like that. So we need to know in the given situation, we have to find either HCF or LCM. So here long forms of these HCF and LCM only say the same thing. So what is it? First of all, we should get meaning of this HCF and LCM in this topic. Second, one thing, that is formulae. We have only 2 formulae in this topic. What is that? HCF and LCM and the numbers, the relation between HCF, LCM and numbers. Based on that, we have some questions. Okay. Then third thing, most important, and that is what? Methods for finding HCF and LCM. HCF and LCM of given numbers, how to find? These are methods, right? And then we have examples, all types of examples, including basics as well as applications. Okay. So here, what is meaning of these HCF or GCD and LCM? You will write afterwards single line for each of these HCF, HCF and LCM. So HCF, that is highest common factor, as well GCD, it is also known as GCD, that is greatest common divisor. So here, as all of you know, divisor means by the number by which we divide. So as all of us know, this is divisor here, and here it is just dividend. So right now, what is HCF or GCD? It is a divisor, that means by which we have to divide given numbers. So greatest common divisor means such a greatest, such a biggest number, largest number, which divides all the given numbers completely, and that's why it is a factor. The number by which the given number is divided or given numbers are divided, that is called factor. Okay. So HCF as well as LCM relate in this thing that remainder has to be 0 only. That is HCF as well as LCM. So highest common factor or greatest common divisor is nothing but it is the largest number which divides all the given numbers completely. While LCM, what is LCM? List or lowest common multiple. So that multiple means the number which is completely divisible. So here, in other words, the smallest number which is completely divisible by all the given numbers. So that is multiple LCM. Is it clear to all of you? So anywhere HCF is related to divisor, that means the place you can just check here for HCF, and LCM is the number which is divisible, that is smallest number which is divisible by all the given numbers. Is it clear? So anywhere, now we come to the point, that is from applications. So anywhere in the situation when we are to find the number by which we have to divide the given numbers, in that case we have to find HCF first of all. Don't bad that if it is asked maximum then HCF and minimum then LCM. No, somewhere if it is asked maximum then it may be finding LCM or vice versa. Is it clear? So we have 2 lines regarding this one. So please take down. You have given heading HCF and LCM. Next line, LCF oblique GCD. You can put in the bracket highest common factor oblique greatest common divisor dash single line, please write. It is the largest number. It is the largest number. It is the largest number by which all the given numbers are. It is the largest number by which all the given numbers are completely divisible. Then next line, LCM, list or lowest common multiple. Dash. It is the smallest number. It is the smallest number which is completely divisible by all the given numbers, which is completely divisible by all the given numbers. Okay. So because of these two lines, you are able to check in the given situation to find either HCF or LCM. Is it clear? In some of the applications, it may be you may need to find HCF, but after that one, whatever is asked, it may be something more to do in that. After getting HCF or LCM, we need to again proceed in any particular situation given. Okay. So after this one, as I said it earlier, first of all, we should get meaning of this one. Then second is now formulae. As I said, there are two formulae in this topic. So please take down. You write down there formulae. First one, LCM is equal to HCF into product of uncommon factors. LCM is equal to HCF into product of uncommon factors. Second one, product of two numbers is equal to HCF into LCM. Regarding these two formulae, I would like to tell you something. First formula is to be used when we have to find LCM by factorization method. And this is to be used when we are getting factors of each of these numbers separately. Is it clear? So multiplying HCF of those numbers by product of uncommon factors, that we get LCM. That is one thing. Okay. You may ask me, are we getting that LCM by factorization only taking separate factors? No, we are not getting. But means we have the factorization method getting without separate factors. Okay, we'll do that. But when the question is asked in reverse direction, in reverse, then we must know these things. Okay. For that only we have to get the first formula. Second one, this second formula is applicable only when there are two numbers. There are only two numbers. Product of two numbers is equal to HCF into LCM means what? If you take any two numbers in the world, any two numbers, whatever is their product, same is the product of their HCF and LCM for all the time. But this is applicable only for how many numbers? Two numbers. Don't get panicked when there are three numbers and we are not supposed to use this formula because uncommon factors in two are exactly a different one. Are you getting me? But if there are three or more numbers, there may be some uncommon factors which may be common in any of the remaining again. Is it clear? We'll do afterwards. Right now, you should remember only one thing. You should get only one thing, that this second formula is applicable only when there are how many numbers? Two numbers. So that is this formula point of view. These are only two formulas. Is it clear? Now I would like to give you methods. So please take down, write down there, subtitle methods for finding HCF and LCM. Methods for finding HCF and LCM. Okay, listen. There are three methods for finding HCF particularly, and two methods are for finding LCM. Okay, so we'll enlist first of all of these three. First two are common for both HCF and LCM. So first one is list method. First one is list method, making list of divisors and multiples like that. List method. Second one is factorization. Second one is factorization. So these are common for HCF as well as LCM. Third method is only for HCF. Okay, so third method, continuous division method for HCF only. Continuous division method for HCF only. Is it clear? Now let me tell you, by all these three methods, we'll find first HCF and then we find LCM also by first two methods in a single example only. Because we have to just check our basics. That's why. Listen, in book of any board, that is maybe state board, NCERT or CBSE board or ICSE board, there are only three methods given in these books, in any of these books, of which list method that indicates only listing divisors as well as multiples or multiples. So this is not feasible in exam hall. This is not feasible in traditional question, means conventional also conventional maths as well as competitive exams maths. Here, list method, that means when we have to find multiples of the given numbers, so we should know tables of those. We know tables of 30 only maximum. So if these are three-digit numbers or comparatively greater numbers which are greater than 30, then we don't have multiples of those. Means we should buy those tables then. So instead, so list method is not to be used in exam hall. Okay, but what is the concept of HCF and LCM? For that we have to learn this one. Second thing, factorization. Factorization method is the only method to find both HCF and LCM in exam hall. Right? That is factorization. Again, there are two styles of factorization: taking separate factors as well as taking common factors. So these are two styles of the factorization. Okay, and continuous division method, as I said, it is applicable for HCF only. Okay, so write down in your notebook, just you put down a question only, a very simple question. Even if you can answer within no time, please don't answer that one. Find HCF and LCM of. Find HCF and LCM of 24 and 30. Find HCF and LCM of 24 and 30. Listen, all of you can get answer, but right now, look at your first one is which method? List method. So we have to form list of divisors and multiples. So list method for finding HCF, we have to get list of divisors. So here I would like to ask you, divisors of 24. All of you present here, offline as well as online. You know, divisors of 24 means the number by which 24 is divisible, right? So you can count yourself and you just tell me the final number. How many divisors of 24 are there in all? Take your own time. What is my question? Are you getting my question? How many total divisors are there of which one? 24. How many divisors of 24 are there? Online friends, you can unmute and talk, or you can put in the chat box also.
5, sir.
Okay. All right. So when you count all those divisors, how many are these in all? Okay. Then you will come up to 8 and you will stop there. 8, 8. Those who are saying 7, they know 1 and 24. Okay. So here, let me tell you proper method to get all these. We are doing this because in exam hall, not to miss any of the possibility. UPSC is known for asking questions related to how many possible numbers are there, like that. So they ask possibilities. So that's why we should get all these. So not to miss any pair or any number, any possibility, we should have proper direction to answer such question. So divisors of 24, it is asked. So 24 being natural number, it is divisible by 1. Any natural number is divisible by 1. So you have to imagine the given number, whether it is divisible by 1, 2, 3, 4, like that. You will not miss any of the divisor. So how it is? Divisors of 24. 24 is divisible by 1. So 1 into which number is 24? 24 itself. So 1 and 24 are the divisors, first pair. Then is 24 divisible by 2? Yes. So when 24 is divided by 2, we get 12. The another question means another divisor or divisor of 24. So 2 and 12 is another pair. Then is 24 divisible by 3? Yes. 3 8s are, so 8 also. Is 24 divisible by 4? Yes. 4 6 are 24. Is it clear? Because of now 4 and 6 in between, only a single number 5, by which it is not divisible. So we are getting 4 pairs of different numbers by which 24 is divisible. So we have divisors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24 itself. Is it clear? So this is list of divisors of the given number 24. Now divisors of 30. Again, you can imagine the same. 30 is divisible by 1, 30 is divisible by 2, 30 is divisible by 3. No, 30 is not divisible by 4. 30 is divisible by 5. 5 6 are 30. So next is 6. 5 6 are 30. Then 10, 3 10s are 30. 2 15s are 30. And 1 30s are 30. So we have, by chance, this number is also having 8 divisors. Not necessarily each number should have 8 divisors, but right now, coincidentally, we are getting for both these numbers. Divisors are 8, of which are common. So 1 is common. 2, the factor 2 is also common. Factor 3 is also common. Factor 6 is common. Now after 6, there is no common factor, common divisor for both these two, and hence the LCM is 6. Are you getting? Is it clear? We are not finding LCM by this method, only to check, only to get where to stand LCM, and the numbers. Is it clear? So that is what we are having LCM of 24 and 30, or GCD of 24 and 30 is 6. Is it clear? Okay. Now from LCM point of view, here we have multiples of 24. What do you mean by multiple? The numbers which are divisible by the given number. So in multiples of 24, that means the numbers which are divisible by 24. So which is the smallest multiple of 24? 24 itself. Immediateness is 48, then is 72. In other words, it's 24/7. Is it clear? So what is that? 24, 48, 72, 96, 120, 144, 168, and so on. So these are multiples are infinite. Divisors are limited, or you can say finite, but multiples are infinite. Okay. So multiples of 13 are, what are those? 30, 60, 90, 120, 150, so on. We have to stop here at 120 only because it is common to both. And the first one, only the smallest one. So their LCM is 120. Are you getting me? Now, even though all of us know what are the basic things, we should realize the same. What is it? LCM of, sorry, LCF of 24 and 30 is 6, and LCM of 24 and 30 is 120. So in this connection, you just need to get all these things very basic. LCF is nothing but by which given numbers are divisible. So because of that, it is for sure 24 and 30 must be divisible by 6, and these are as well. LCM is 120 must be divisible by the given numbers 24 and 30. Because of that, here by LCF the numbers are divisible, and by numbers LCM is divisible. So but obvious, LCM of the given numbers must be divisible by their LCF. Is it clear? Are you getting me? Here, LCM of these given numbers is 6, by which 24 and 30 are divisible, and by 24 and 30, LCM 120 is divisible. So, but obvious, 120 must be divisible by LCM, that is by 6. So, anywhere you may be asked question like this one, that suppose we are given LCM of some numbers, and which one of the following cannot be LCM like that. So, the number which is divisible, LCM by which from the options, if it is divisible, then it can be possible LCM. But the number in options, if it is not dividing the LCM, then that cannot be their LCM. Are you getting? Is it clear? Okay, we'll solve examples afterwards. We have lots of examples in our question bank. Okay, we'll getting this method only to check status of the status of HCF, LCM, and the numbers. So right now, if we have studied already, or just right now we'll do the same. HCF of the given numbers are smaller than the numbers. No doubt, because these are divisors. What can be the maximum HCF of the given numbers? Are you getting? So let me tell you the same. If we are getting HCF of the given numbers, so those numbers may be 2, 3, 4, whatever. HCF cannot be exceeding the smallest of these numbers of which we are finding HCF. Are you getting? In other words, 24 and 30, whatever may be the numbers of these two numbers, whichever is the smaller number, HCF is not exceeding that smaller number. I'm saying the same thing. As well, LCM is also not less than the greatest number. Are you getting me? LCM cannot be less than the number only. In other words, I want to say the same. Is it clear? Okay. So that is list method we are getting. After this one, right on there, factorization. 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 You will write afterwards. First of all, please look at here. Factorizing separately means whichever are the numbers given to find their HCF and LCM, taking separate factors of these numbers. So we have factorizing separately. We have the numbers 24 and 30. No, so 24 has factors 2 into 2 into 2 into 3. Are you getting me? 2 into 2 into 2 into 3. Listen, here writing any number in factorization, that means writing that number in the product of prime numbers. So here, if you have forgot how to get those factors, 24 has factors. So divide the given number by prime numbers only, starting from the first prime number, that is 2. So 24 being divisible by 2, we have question is 12. So you need to continue by dividing by 2 till we get that the number. So we have here, when divided by 2, we get these one. Now 3 being prime number, we have to divide it by 3 only. So 24 has factors 2 into 2 into 2 into 3, as well 30 has factors 2 into 3 into 5. So to find their HCF, we have to take common factors in all. So we have, what are the common factors in these? 2 is common factor, but there is another factor also common in both. If there have been only single factor common in both, then that is the only HCF. But if there are 2 or more factors common, then we have to multiply those common factors for finding HCF. So 2 is common here as well. 3 is also common to both. Now remaining are in first number 2 into 2 and in the second number 5. So these are uncommon only. So common are only 2, which are those 2 and 3. Their product is 6. So that is HCF is 6. Is it clear? Now to find LCM, as I said it earlier, formally those 2 formulae we have written, out of which first formula is used here only. So LCM is equal to LCF into product of uncommon factors. LCF, how much it is? 6. Now uncommon factors from first number 2 into 2 and from the second number only 5. So when we do product of these one, it comes to 120. Is it clear? So LCM is 6 and LCM is 120. So we did this one by factorizing separately. Listen, in exam hall, you are not supposed to use this method. Don't practice this one in exam hall because it takes lots of time. You may say how, if as there are only 2 numbers, it is okay. If there are 3, 4, 5 numbers like that, so in that case, common in all will be in HCF only. But suppose there are 3 numbers of which we have to find HCF as well as LCM. So HCF, that is common in all. But in case of LCM, after that all common factors are over, now means common in all are over. Now out of those 3 numbers, if there are factors which are common in only 2 but not in the third, will not be considered in HCF, but that has to be considered in LCM. In that case, the factor which is common in only 2 is to be put only once. Like that we need to do in factorizing separately. If there are 4 numbers, we have to do the same thing. The factors which are common in any 3 only, we have to put only once. Like that we have, we need lots of time. Instead, we have another method, and that is factorizing commonly. So we'll do that one first of all, and then you will write both. Factorizing commonly. So factorizing commonly means what? We have the 2 numbers 24 and 30. Whichever are the numbers given to find HCF and LCM are to put in line. First of all, and remember, please listen, 24 and 30, these are 2 numbers of which we have to find HCF first and then LCM. To find HCF of the given numbers, we have to divide by prime numbers only, and by those prime numbers, all the numbers must be completely divisible. Then these are only to be taken for first HCF. Is it clear? So 24 and 30 being even numbers are divisible by 2, no doubt, commonly. So we have 12 and 15 are the quotients. After getting these 2 and 15 quotients, out of which 12 is even but 15 is not, and that's why 2 is not common divisor for these. You have to think of another common divisor, so which is common to both, and that is what? 3. So by 3, when we divide, we have 4 and 5 are quotients. Now, no any prime number commonly dividing 4 and 5. Is it clear? Why? Because 4 and 5 are consecutive natural numbers also, and any 2 consecutive natural numbers are not divisible by any common prime number. Is it clear? Now, the most important thing I would like to tell you, and that is what? By which we are dividing the given numbers for finding HCF as well as for finding LCM also. We need to divide by prime numbers only, compulsory. By which numbers we have to divide? Prime numbers only. Because of that, we can get HCF as well as LCM. Is it clear? To get LCM means smallest number which is divisible. For that, we have to divide by prime numbers only. Is it clear? Now, 4 and 5 being consecutive natural numbers, they don't have common divisor, and that is here the numbers by which we have divided the given numbers commonly. These are only 2. What are those? 2 and 3. Their product is what? HCF. Are you getting me? Now, if there are only 2 numbers, then you can multiply this HCF by 4 and 5 directly. So 4 5 are 20, 20 into 2 3 are 6. 120 will be HCF. Sorry, LCM. So LCM. Is it clear? But from procedure point of view, I have to continue right now. So here 4 and 5 are the questions we are getting which don't have any common prime number as a no common divisor as a prime number. Now you can divide 4 and 5 by prime numbers. So you have to just check by those prime numbers we have to divide only at least one of these numbers must be divisible. So by which prime number you want to divide here right now? Okay, by 2, you have not said, but right now I will tell you. So here we have to divide by 2. So when we divide it by 2, we have 4 when divided by 2 is 2 only. 5 is not divisible by 2. Put 5 as it is. So the number which is not divisible have to be put as it is. Now we have by 2 when divided it is 1. Here is 5. So wherever there is 1, we are not considering. That means we are ignoring. So here both ones are there. So when we get all ones in the end, we have to stop there only. And now from very first prime number by which we have divided till the last one, whatever of the prime number, their product is nothing but LCM. Is it clear to all of you? Got this? Okay. So copy now. So by which we are dividing these numbers must be prime numbers compulsory. Okay, finish. Okay, finished. Now, the third method, meaning that is what? Continued division method, and is for HCF only. So let me tell you something regarding continued division method. So continued division method has one limitation. You may ask me then why are we learning that one? Yeah, limitation is what? We can find HCF of two numbers only by this method. We can find HCF of two numbers only at a time. We can find HCF of two numbers only. So this method is to be learned because there are three advantages. There are three favors. What are those? First is it saves time. First thing. Second thing, we can find HCF of comparatively greater numbers, maybe 3-digit numbers, 4-digit numbers, 5-digit numbers also. We can find by this method. And third one is when factorization is not feasible. Means if the factors directly, which are the numbers given, if those numbers are the factors which are more than 30 only directly beyond our tables, then in that case it is not feasible to find HCF or LCM by factorization. Is it clear? In that case, this continued division method is more useful. So as I said, this continued division method for HCF is applicable for how many numbers at a time? Two numbers. Of those two numbers, listen. First step of this method is of these two numbers. Your name indicates only divide the greater number by the smaller number. Of those two numbers, divide greater number by smaller number. So as we are solving the question that is finding HCF by HCF of which two numbers? 24 and 30. Out of those 24 and 30, the smaller number is 24. By 24, we have to divide the greater number 30. Is it clear? Listen. So first step, dividing greater number by smaller number. So try to get division, maximum quotient, and getting remainder, whatever. So 24 ones are 24 only we can do. Is it clear? Remainder is here 6. So what is this method? When we are finding HCF by this method, dividing greater number by smaller number. If remainder had been 0, then divisor itself would have been our HCF. Are you getting me? Instead of 6, if it had been 0, then 24 is the divisor, we have the HCF only. But here it is not, means 6 is non-zero remainder. But we know that in any division, remainder is smaller than divisor. Because of that, if it is non-zero remainder, so remainder is 6, has to be smaller than the divisor, that is 24. So we have to continue dividing here divisor of that one by the remainder. So dividing divisor by the remainder every case here onwards. So we have 24 is to be divided by 6. Are you getting me? First step, dividing greater number by smaller number. If remainder had not been 0, then by that non-zero remainder, we have to divide the divisor of the first one, the previous one. So 6 4s are 24. Remainder is 0. Being remainder 0 in this case. At the place where remainder is 0, the divisor itself is our HCF. Is it clear to all of you? Got it? So what is this method? When two numbers of which we have to find HCF, divide the greater number by the smaller number. And if remainder had been 0, then divisor would have been HCF. If remainder is non-zero, then dividing divisor by the remainder till we get remainder 0. Means what? You need to continue the process of dividing divisor by the remainder till we get remainder 0. So where the remainder is 0, at that time, whatever is the divisor, that is our HCF. Don't mind that whatever is the question. Is it clear? We are insisting for HCF, that is divisor only. Is it clear? Got this? Okay. So for that, from practice point of view, I would like to give you example. Before that, have you taken down this one? 30 divided by 24 and all this. Okay. So you just write down there. Find HCF of 126 and 308. Find HCF of 126 and 308. These two numbers are 126 and 308. On dividing 308 by 126, because greater number is to be divided by the smaller one. 126 double 252 is to be subtracted from 308. Maximum this can be subtracted. So remainder is how much it is? 56. Now by 56 we have to divide 126. 56 into 2 is 112. So remainder is 14. Now by 14 we have to divide 56. So that is continued division. Every time we have to divide the divisor by the remainder. So 14 4s are 56. Now being remainder 0, the divisor at this place is our HCF, and that is 14. Is it clear? Got this one? Okay. So after this, as we have seen methods, online friends, all of you did absolutely correct, but from online friends, Abhishek, you answered that 4, and that is quotient as I said it. So we don't want that quotient. We don't mind that quotient. We have to just take divisor. So where the remainder is 0, the divisor is our HCF, and that's why it is 14. HCF is 14. Is it clear? Okay. So we have, as discussed in the initial, that is what in this topic. Just a minute. We have what is HCF, LCM, that is meaning, what are the formalities related to this, and we have checked methods for finding HCF and LCM. Before going to examples, I would like to give you two things. That is HCF and LCM, HCF and LCM of the numbers in exponential form, and HCF and LCM of fractions also. So we have to check these two things, and then we are able to solve any of the questions in any competitive example. So right now here, you take on one example. Find HCF and LCM of 144, 216, and 252. You just write this much only. We are solving by basic things and all. Okay, listen. Okay, find HCF and LCM of 144, 216, and 252. Here, taking separate factors. 144, 216, and 252. Here we have 144 has factors 4 times 2 and 2 times 3. These are factors of 144. Okay. Now factors of 2 and 6. 2 and 6 being 6 cube. 6 has factors 2 and 3. So 2 and 6 is 2 into 2 into 2 into 3 into 3 into 3. And for 252 has factors, you will get 2 into 2 into 3 into 3 into 7. So let me tell you all basic things regarding this one. So FCF of the given numbers to find this one, you have to check different types of factors in the given numbers. So 144 has factors of only 2 different types. What are those? 2 and 3. Same is in case of 2 and 6 also. There are only 2 types of factors in 2 and 6. But in 252, there are 3 types of factors, which are those 2, 3, and 7. So common to all. I'm saying common to all. How many types of factors are these common to all? 2 types. Which are those? 2 and 3. Okay. Now I would like to ask you here, as the 2 and 3 are the common in all. So my question is, the factor 2 is common in all maximum how many times? Twice. The factor 2 is common in all maximum twice. Is it here? Here 2 into 2. Here is also 2 into 2 and here is also 2 into 2. So 2 into 2 will be in FCF. Okay. Now we have 3 is also common to all. Again, 3 is maximum common how many times in all 3? Again twice. Here 3 into 3, here is 3 into 3, and here is also 3 into 3. So into 3 into 3. Don't try to get product. You just check this one. 2 into 2 into 3 into 3. That is HCF. Now in case of LCM, first of all, HCF 2 into 2 into 3 into 3 already here. Now uncommon factors. In first number, what are uncommon factors remaining? 2 into 2. In the second number, which are remaining? 2 into 3. And in the third, 7 only. Is it here? Now, common in all are 100. That's why HCF we got. Now, to continue for LCM, we have to multiply HCF by uncommon factors. Now, friends, check here. In first, second, and third, we have common in all are 1, but there is one factor common in only 2. First and second. What is it? 2. So here is 2. Here is also. Here is 2. So for that, we have to put only once 2. Is it here? Okay. Now, in first number, only the factor 2 is uncommon remaining. In the second number, 3 is remaining. And in the third number, 7 is remaining. So we'll put this 2 into 3 into 7. Are you getting me? Is it clear? Now, so you may ask me, so what is the different one in this? So if it is in exponential form, see, to find HCF and LCM, we have followed the procedure. Common in all for HCF. And after getting HCF, multiplying by uncommon factors, and for that, where there is a common factor 2, common in first and second number only, had to be taken only once, and that we did, and we got this answer. Okay. Now in exponential form, we have to express these things. So here 144 has factors 2s and 3s. So we have here this one is nothing but 2 raised to 4 into 3 square. Are you getting me? Yes. Then here 2 and 6 is 2 cube into 3 cube. Then 252 is 2 square into 3 square into 7. Now HCF has 2 square into 3 square, and for LCM it is how many times is 2 in LCM in all? 4 times. Twice in HCF, and then 2 is common in first and second, and again another 2 is remaining only in first. Okay. So 2 raised to 4. Then 3 is 3 times, and 7 is once. Now you can analyze these things. Let me tell you what is it. When we have, see, based on these, you may be asked question. For that, after analysis only directly you can have current or direct material. What is it? When we are having the numbers in exponential form, we have base and powers. So in HCF, I'm saying in HCF, what are the base? 2 and 3 in HCF. Why? Because these are common in all. So while finding HCF of the numbers in exponential form, take only common in all base for HCF. Is it clear? Okay. And in LCM, we find which base? 2, 3, and 7. So all base which are present in the given numbers, all. Even if in only one number, then also it is to be taken in LCM. That is thing. Okay. So while finding HCF, we have to take only common base in all. While finding LCM, we have to take all base. Okay. Now decide their powers. So in HCF, 2's power is 2, right? And in LCM, 2's power is 4. Is it clear? So what is the status of these? Let me tell you. In the given numbers, the 2's power is minimum 2 in one of the numbers. Are you getting me? Is it clear? So in other words, as well as 3's powers in the given numbers are 2 and 3. So 2 is the power of 3 as well as 2 in HCF. Why? Because these are minimum. So to find the HCF of the numbers in exponential form, take common base in all. Take only common base in all with minimum powers. And for LCM, we have to take maximum powers. So 2's power is 4 in one of the numbers, which is maximum. 3's power is 3 is maximum, and 7 is the number only one of the present in only one number. So that is power is not given. That is by default it is 1. Is it clear to all of you? So here you can directly come up with these things that without doing any procedures. When we are given numbers to find HCF and LCM of exponential form, without doing anything, you have to check what are the common factors in all with minimum powers for HCF, and take all base with maximum power for LCM. Is it clear? Are you getting me? Okay. So write down this one. Listen, you are getting this concept. When we apply this one, again it will be more clear when you apply this here. when you finish this one up to 7, we'll write single sentence regarding this one. Till this finished. Right down there. To find HCF. To find HCF of the numbers in exponential form. To find HCF of the numbers in exponential form, take only common base in all. Take only common base in all. Take only common base in all with their minimum powers. Take only common base in all with their minimum powers. And for finding LCM and for finding their LCM, THIL, and for finding their LCM, take all base with maximum powers. Take all base with maximum powers. Take all base with maximum powers. Finished? Okay. Then please give subtitle HCF and LCM of fractions. HCF and LCM of fractions. Dash. Okay, right down there. The given fractions are to be expressed in common fractions to their lowest terms. Okay, you wrote what is it? The given fractions, whether these are common or decimal, doesn't matter. First of all, these are to be brought in which type of fractions? Numerator, denominator, that is common fractions. To their lowest terms, it's the most important. To their lowest terms. Are you getting me? No any common divisor should remain there for numerator and denominator. Is it clear? So that we have to bring them to the reduced form, in other words, to their lowest terms. Okay. So then next line we will write this relation. HCF of fractions. HCF of fractions equal to HCF of numerators upon LCM of denominators. Listen, there may be two or more fractions. After getting each of these to the common fraction to the lowest term, in common fractions to the lowest terms, we have HCF of all those fractions is nothing but it is again a fraction whose HCF is whose numerator is HCF of all numerators, and a denominator is nothing but LCM of all denominators of the given fractions. Are you getting me? Is it clear? Now next line you write another LCM of fractions. What is LCM of fractions? LCM in the numerator, LCM of numerators upon HCF of denominators. So you can get the sense. LCM of given fractions is nothing but again it is a fraction whose numerator is LCM of all numerators and whose denominator is HCF of all denominators. Is it clear? So in this only you need to put numbers. Okay. All right. So these are all the basic things related to the topic HCF and LCM. So we have seen meaning of HCF and LCM. HCF is nothing but the greatest or largest number which divides all the given numbers completely. LCM is nothing but the smallest number which is divisible by all the given numbers. Then we have two formulae. LCM is equal to HCF into product of common factors. Then second formula is product of two numbers is equal to HCF into LCM. Then we had three methods of finding HCF and LCM. Three methods of which first is this method, second is factorization, and third is continued division method for HCF only. Then we have here as we got relation among the numbers in exponential form and what are HCF and LCM, and in the end we have HCF and LCM of fractions. Is it clear? Now you are able to solve any question related to HCF and LCM. So we are solving those right now. I would like to share on our screen. Yes, HCF and LCM of numbers. So the first numbers. We start with positive note. Find HCF and LCM of 30, 42, and 84. Okay, 30, 42, 84. Before that, before to start to solve this one, let me know how many of you have got your answer at option C. Okay, so those who are not getting for them, okay, here 30, 42, and 84. all being even numbers, are divisible by first prime number, that is by 2. So when 30, 42, and 84 are divided by 2, we get 15, 21, and 42 are the questions. 15 and 21 being odd, not divisible by 2, right? We have to think of another prime number commonly dividing all the three numbers. If it is, then we have the prime number 3 by which all are divisible. 3 5s are 15, 3 7s are 21, and here is 14, 3s are 42. So we have on dividing the numbers by 2 and 3 commonly. Quotients are 5, 7, and 14, of which 5 and 7 being prime numbers. No any common divisor will be there. Is it clear? Because of that, here there are only two numbers common prime numbers which are dividing all. So their LCM has to be 2 into 3, that is 6. Right? Now we have to continue for LCM. So for LCM here, 5, 7, and 14, of which 7 and 14 are divisible by 7. So you can divide it by 7. 5 is as it is to put. 7 1s are 7, 7 2s are 14. Then we can divide by 2, 5, 1, 1, and when divided by 5, 1 each we are getting. Product of all these numbers from start to end, all prime numbers by which we have divided the given numbers, they are product. So 2 3s are 6, 6 7s are 42, and 2 5s are 10. So 42 into 10, that gives you 420. So LCM is 6 and LCM is 420. Is it clear? Okay. Frankly speaking, I would like to ask you, is there anyone who has got answer option D for Delhi? Okay. So they did, I think, separate factorizing. They factorize separately. Okay, so how it is 30 is equal to 2 into 3 into 5, 42 is nothing but 2 into 3 into 7, and 84 is 2 into 2 into 3 into 7, right? So we have common to all numbers, the factors are 2 and 3, which are common to all. Is it clear? So HCF is 2 into 3, that is 6. Okay, now uncommon factors remaining in those three numbers are 5 in first number, 7 in second number, and in third number 2 and 7. Is it clear? Right now let me tell you. So this 7 is common in second and third, but not in first. That's why it is not taken in LCM. But in case of LCM, when we are multiplying LCM by uncommon factors, we have HCF is 6. Now this 7 is to be written only once for this 2 times 7. Are you getting me? So we need to check like this only. As there are three numbers. If there are 4 numbers, then common in all 4 will be in HCF, but common in any 3 will not be in HCF. But common in any 3 will be written only once in LCM. Is it clear? So instead, it is better to go by commonly factorizing. Is it clear? Okay, no problem. You can get by this approach also, one and the same. So for twice 7, we have to write only once 7. Then what are the factors remaining there? 5 in the first number and 2 in the third number. So into 5 into 2, that gives you how much? 420. Is it clear? Okay, so one and the same thing. HCF 6 and LCM is 420. Okay, then second question. LCM and LCM of 26, 56, 104, and 182 respectively are. We have to find LCM. In other words, we have to find LCM and LCM of given numbers. Yes. Answer is option A. How many of you have got? Please raise your hands. Okay. Don't talk, please. Find LCM and LCM of 26, 56, 104, and 182. So all being even numbers, 26, 56, 104, and 182, all are divisible by 2, being even numbers. So on dividing 26 by 2, we get 13, then 28, then 52, and 91. Now, first question is 13. Question is 13, being a prime number, and 28 has factors. They don't have nothing to do with the factor 13, with the number 13. So common divisor is no more. So because of that, HCF we are getting, and that is what? Only 2. Now you can continue for LCM. For LCM, now you can divide the given numbers in any sequence. Sequence doesn't matter. Only we have to divide by prime numbers, and at least one of the numbers must be divisible by those prime numbers. So by which number you want to divide here onwards? Immediate next, by which number you will divide? If you divide it by 13, what happens? 13 ones are 13. 28 is not divisible by 13. Then 13 4s are 52 and 13 7s are 91. Now by which number you will divide? If we divide it by 7, what happens? 1 is as it is. 28 when divided by 7, it is 4. 28 when divided by 7 is 4. Here is 4 as it is because 4 is not divisible by 7. And 7 ones are 7. So of the 4 numbers, we are getting in the end one twice. Now, other than the number 1, we have 4 which is common to both. So in this case only, you can divide directly by 4. In this case only. Number oriented. If there have been different numbers, then we have to divide by prime numbers only, no doubt. Are you getting me? Okay. If anywhere the different numbers are there, we have to divide by prime numbers only. Here in this case, you can divide by 4 directly because we can get all ones only in this. All ones after that. Now, product of all these is LCM. And that LCM you will get by multiplying these. 728. HCF is 2. LCM is 728. Is it here? So after getting HCF, whichever may be your sequence by which we are dividing the given numbers by prime numbers, doesn't matter what is the sequence. Only you should have correct calculations. Okay. So answer of this question number 2 is option A. Now, third question. So online friends, 4 online friends have answered this one. Okay. How many of you have got your answer? That is option D. Okay. Listen. For those who are not getting answer, first of all, and then we'll discuss one thing. As this question is given, what is HCF of 2923 and 3239? Let me tell you, in any book, it would have been explained by only one method, and that is continued division method. As soon as we see these numbers, which are 4-digit numbers, and factorization is not feasible. Even we are after getting HCF, we realize the same. Okay, so as soon as we get this question, we realize that there are 2 numbers only of which we have to find HCF. So it is better to apply which method? Continued division method. So by continued division method, in book it will be explained like this only. By continued division method, we have to find HCF. So dividing greater number by smaller number, of these 2, greater number is 3239, smaller number is 2923, right? So in the visual only, you can by looking over these, we can get what can be the quotient 1 only, right? So minus 2923. So here, subtracting 2923 from 3239, we get remainder as 316. As all of you know, 316 is the remainder by which we have to divide the divisor, that is 2923. Listen, in book you will be given only theoretical part, but practically calculations we have to do ourselves. So how to work out these in exam hall? By which we are dividing 2923 is 316, which is a 3-digit number. No doubt we don't have table of 316. But what can be the quotient? You can get easily within very less time. For that, by 3-digit number we are dividing. So that 3-digit number, which is a divisor, you have to just check it is closer to nearest which 100, closer to nearest which 100 I'm saying. It is closer to 300. Are you getting me? For that, we have to keep last two digits of both these numbers silent. Last two digits we have to put silent. So here is a 3 and here is 29. So we have to say 3 stable and check status of 29 there. So 3 nines are 27 and more directly. So don't play with that 3 1 6 into 1 into 2 into 3 like that. Directly come for 9 quotient as 9. So when we are, and listen, we discuss these things only to check what can be the quotient for that only. So we have here 316 into 9 for a while. So 316 into 9, by chance it comes 2844, which is less than 2923. If it had been exceeding, then instead of 9, we would have gone for 8. Like that is trial and error only. So subtracting this one, we have 79 is the remainder. By 79, we need to divide 316. 319 is, sorry, 79 is very much close to 80. So which of which we can say table easily. 80 into 4 is 320. So 79 into 4 will be 1 into 4 less than 320, that is 316. So 79 into 4 gives you 316. Remainder is 0. Being remainder 0. Here, 79 is a divisor that is called HCF of the given two numbers. Is it clear? Okay, that is one thing. Okay. Another thing I would like to tell you, what is it? Even if we don't have any correlation regarding time management in exam hall, but even then, if we are getting the answer in this time, it is acceptable. Means we need that one. Okay, so to get that one, let me tell you. Here, you can go through options also. In book, it will not be given that method. Right now, we should think of practical also. So how can you go through options? Again, means we are not going through options blindly. We are having some approach there. And what is that? Listen. The numbers of which we have to find HCF. By that HCF, both these numbers are divisible, must be divisible. So right now you know in maths that as these two numbers of which we are finding HCF, that HCF has these multiples. So difference between multiples of a common number is also divisible by the common number. That means what? By HCF, 2923 as well as 3239 are divisible. Same, the difference between these two also to be divisible by HCF. Are you getting me? Is it clear? So what is the difference between these two? As these are, even though these are 4-digit numbers, these are much closer to each of these. So difference between these two is 316. Are you getting me? So 316 also to be divisible by HCF. In fact, HCF can be maximum equal to their difference. Are you getting me? HCF can be maximum equal to their difference. And as I said, difference is also divisible by HCF, right? So HCF, sorry, difference is how much? 316. Now listen, as you know in maths, no any odd number is divisible by even number. Are you getting me? No any odd number is divisible by even number. And because of that, the numbers of which we are finding HCF being odd, their HCF cannot be even. And that's why 316 cannot be their HCF. Are you getting me? Is it clear? So you need to divide that 316 by 2 till we get other than the factor quotient other than even number. So when 316 is divided by 2, we get 158. Being again even number, again divided by 2. 158 when divided by 2 it gives you 79. Is it clear? So their HCF has to be 79. And let me tell you that 79 being a prime number, 79 being a prime number, their HCF has to be either 79. If it is not, then only 1. HCF has to be only 1 if both are not divisible by 79. If any one of these, if it is not divisible by 79, then no doubt another will also be not divisible by 79. If one of the numbers is divisible by 79, other has to be divisible by 79. Are you getting me? Because the difference between these two is 316, which is multiple of 79. Is it clear? Now, moreover, I would like to tell you another thing. These two numbers differ by how much? 316. When 316 is divided by 79, we get quotient as 4. That means, let me tell you, 2923. When divided by HCF 79, we get 37 as quotient. We get it is 37 as quotient. So 37 into 79 is 2923. And so but obvious 3239 will be quotient when divided by 79. How much will have been, must have been quotient? 41. Why? Because it is greater by 316 and 316 is fourth multiple of 79. Are you getting me? So when you get factors of 2923 and 3239, you realize that all are prime numbers. 79 is a prime number as well, 37 as well as 41. So no any factor is up to 30. All factors are beyond 30. So because of that, factorization is not feasible in that case. Is it clear? Okay. So these are the things to be discussed because these are not given in any book. You need to know if the difference between these numbers of which we are finding HCF. If it is a prime number, then that prime number has to be HCF only. Okay, we'll discuss that the same thing in the another example. Okay, so is it clear to all of you how to get this one? Being 4-digit numbers, we are supposed to apply continued division methods. Okay, then 4th and 5th questions are finding LCM of 5 and 6 numbers like that. I believe in this thing that you can do at home, right? So in other words, it is homework you can say. So question number 6 directly. So there is something to do from your side. So that's why it's a homework. If you are not getting, actually it is only calculation part. Okay. First of all, read this 6th question. Read this one. Which one of the following pairs is a pair of co-prime numbers? So let me tell you. So only those have a right to answer this question. Those who know what is co-prime numbers. Okay. So write down. I would like to give you one sentence regarding this one, and because of that, you all will be able to answer question correctly. Two numbers are said to be co-prime. Two numbers are said to be co-prime if their HCF is 1, the digit 1, the number 1. Means in other words, they don't have any common divisor as a prime number. They don't have any common prime number as a divisor. So you will check. Why? Because which one of the following means we have to go through options. Now it is made very simple. By looking those numbers only, you can tell me the answer. D for Bombay or D for Delhi? Okay, how many of you are saying D for Bombay? Please raise your hands. Only this much? Rest are saying D for Delhi. Okay, answer is B for Bombay only. 64 and 81. Now listen. The two numbers are said to be co-prime if their FCP is 1, means they should not have common divisor as a prime number, right? 16, first option A, first pair is 16 and 62. Being both 16 and 62 even numbers, their FCF cannot be 1. Whatever it is, doesn't matter. Means when you are solving such a question in exam hall in very less time, as you are getting those both numbers, even numbers, different even numbers, so their FCF cannot be 1. So eliminate that at the earliest. Option C, 21 and 35 both are divisible by 7, so their FCF cannot be 1. Okay, then option D. So those who are saying option D, let me tell you them. Let me tell them 23 stable. When you know 23 stable, 23 4s are 92. So their HCF is not 1. Their HCF is 23. Is it clear? And because of that, option B only the required pair. Listen, even though 64 and 81 are each composite number, but they don't have any common divisor. Any common divisor means by the same prime number, both are divisible. It is not. Why? Because see, as soon as we see the number 64 is 8 square and 8 is 2 cube. 2 into 22 is 8. So 64 has factors all in 2s only. Means what? When we take the number 2 6 times and multiply, we get 64. Same is the case for 81. 81 is 9 square, 9 is 3 square. So because of that, 81 has factors all in 3s. All in 3s. Is it here? So 64 has factors all in 2s and 81 has all factors all in 3s. Is there any common prime number as a factor? No. So because of that, these are co-prime. So any two numbers can be co-prime if their FCF is 1. No doubt that any two prime numbers are co-prime. Are you getting? Any two prime numbers are co-prime because they don't have any common divisor. But two composite numbers can also be co-prime. I'm saying co-prime. As we are getting 64 and 81, even though both are composite numbers. Got this? Got it? Okay. Then let me tell you regarding 7th question. If it had been solved in any book, then by procedure, how it would have been solved. And as I said it earlier, in state board book, 7th standard, they have given this topic in detail. Okay, so not necessary right now because I have given all these things here. So what is FCF of 204, 1190 and 1445? We have to find only FCF of how many numbers? 3 numbers. As I said it earlier, continued division method we can apply for 2 numbers at a time. So the FCF of 3 numbers we can find by that method, but for that we have to adjust that method. How it is? The numbers of which we have to find FCF. If these are 3 numbers, then first of all, pick the largest 2 numbers of those 3. Which are those? 1190 and 1445. Find FCF of these 2 largest numbers first of all by this method. We'll get some FCF, no? That FCF and the remaining smallest number of these 3. Again, we need to do the same procedure again, right? So second time when we are getting FCF, that is the final FCF of all these 3 numbers. Is it clear? So we have 1190 and 1445. We have by 1190 we have to divide 1445. 1190 ones are that much only. The remainder is 255. By 255 we have to divide 1190. So when we know 25 4s are 100 like that. Here 255 into 4 gives you 1020. So remainder is 170. By 170 we are dividing 255. We have 170 ones are 170. Remainder is 85. And now you will be very much pleased. By 85 we divide 170. 85 double is 170. Remainder is 0. So FCF we are getting in the first one is 85. Now 85 is FCF and one of the numbers remaining of the 3 numbers, the smallest one remaining, which is that 204. So of these 2, maybe FCF of the first 2 numbers or the third number, whichever may be greater or smaller, doesn't matter. Divide greater number of these 2 by the smaller one. So by 85 we have to divide 204. So 85 2s are 170. Remainder is 34. By 34 we have to divide 85. 34 2s are 68. Remainder is 17. By 17 we have to divide 34. So 17 2s are 34. Remainder remainder is 0. Whatever is FCF in the second one, that is the required FCF. So that is 17. Is it clear to all of you? Okay. In this example, suppose you are trying to solve by this method. After getting FCF of the 2 largest number only, if you check options, then also our job is over. What is it? FCF of the greatest 2 numbers is 85. And by which of these 4 options 85 is divisible? That you need to check. Is it clear? Because required FCF is FCF of the 2 largest numbers and the remaining number by FCF. Is it clear? So that is what FCF 85 must be divisible by the required FCF again. Okay, that is one thing. Second thing, you can directly go through options also. How it is? Of these 4 numbers by elimination, by eliminating remaining 3 options. By eliminating 3 options, we get remaining the answer. Here, as we have discussed before, 1 4 4 5 being odd, it is never divisible by even number. Because of that, 18 cannot be there FCF as even number. Now, here of these 3 numbers, 204 is the smallest. You can target that one by dividing each of these options. So 204 is not divisible by 21. Are you getting 21 tens are to 10, and 204 is only 6 difference with that one. So 21's multiple must have difference of 21 and multiples of 21. So 21 cannot be the answer as well. By 19 also not that 204 is also not divisible by 19. So option A, B, and C are no more. That's the answer is option D. By eliminating, you can get the same. In exam hall, if whatever is the reverse mindset, you can continue with that one. Is it clear? Okay. So that was the 7th question. Got it? Question number 8. Listen, no doubt, you all present offline mode as well as online will get absolutely correct answer. But I would like to give you practical thing regarding this one. we have to find the LCM of the given two numbers. Don't talk, please. And whatever we are discussing things, these are not given in any book. These are practical things we need to apply in exam hall. We have to find LCM of the given numbers. To find LCM, there is only one method to be applied in exam hall, and that is factorization. Right? In case of factorization method, to find LCM, first of all, if we find FCF, then it is comfortable to find LCM. Right? So first of all, we need to get FCF of these two numbers. Being these very much close to each other, we can find the difference between these two orally within no time. Can you tell me what is the difference between 148 and 185 orally? 37. How it is? 148 is very much close to 150. So 150 and 185, the difference is of 35 orally. Right? And here two more. So it is 37. Most important sentence from practical approach as well as calculations point of view. If the difference between the two numbers of which we are finding FCF is a prime number, 37 is a prime number, right? If such a difference between these two is a prime number, then their FCF has to be that prime number only. If not, then those two numbers have to be co-prime only. Are you getting? Is it clear? They must be divisible by difference between these two, right? So 37. If one of the numbers is not divisible by 37, if we check, other also should not be divisible because they differ by 37. And if one of the numbers is divisible by 37, other has to be. So here, when we divide 148 by 37, we get quotient as 4. Are you getting me? So, but obvious, 185 must be the next multiple. That is fifth one. Is it clear to all of you? Okay. So because of that, we have LCM is FCF, that is 37, and uncommon factors from these two numbers are 4 and 5, respectively from first and second number. Is it clear? Okay. So whatever is the product that you will do calculations, it is 740. Again, in these, see, more you think on it, more will be you will be having benefits. So what is that? Listen, 37 into 4 into 5 it is. 37 into 4 itself is a number, first number. To get LCM, we need to multiply by 5. That is 5 is uncommon factor from the second number. Are you getting me? As well, if we get here 37 into 5, if we do 37 into 5, to get LCM, we need to multiply by 4. 37 into 5 is nothing but one of the numbers. Multiply one of the numbers by uncommon factor from the second number. Are you getting me? 37 into 4 needs to be multiplied by 5, and 37 into 5 needs to be multiplied by 4. So 4 and 5 are uncommon factors of the numbers given. Is it clear? Got it? Okay. So when you get spare time at the earliest, please do revision on these. Because of that, you will remember the same. Okay. Then ninth question, you are having something different from the previous one, but all of you present here are getting answer in very less time. Online friends, both of you are correct. So all of you should raise your hand. What is the answer? Option A. How many of you are? Please raise your hands. All of you. Okay. Listen. As we have discussed these things, these are in exponential form. To find FCF, very simple one. To find FCF, take common base in all expressions. Only common base in all. So in first expression, what are the base? 2, 3, 5, 7. In the second also 2, 3, 5, 7. But in the third, 3, 5, 7, and 11. So common in all are 3, 5, and 7. So common in all 3, 5, and 7. Is it clear? So as you have written in your notebook again also, that for finding FCF of the numbers in exponential form, we have to take only common base in all the given expressions with their minimum powers. With their minimum powers. So minimum powers of 3, 5, and 7, where do they stand? Here, 3's power is 3 in the first number. In the second, it is 3 square. In the third number, it is nothing mentioned, that is 1. So minimum is 1. So for 3's power is 1. Then for 5's power in again third number is minimum 1. And in the third, 7, again 7 has minimum power 1 in the third number. So we need to do only 3 into 5 into 7. That gives you 105. Is it clear? Got it? Okay. Even though it is not asked what is LCM, but suppose it had been asked, you have to tell me orally. Means in exponential, you just tell me in exponential form. Not necessary to multiply. You just tell me orally. So here, to find LCM of the given, it is not asked, but and you don't find in options also. So here we have LCM is 2, 3, 5, 7, and 11. All base. Are you getting me? to find LCM, we have to take all base with their maximum powers. So what is maximum power of 2? 4 in the second number. Then 3's power is 3 max in first number. 5's power max 3 in both first and second number. 7's power 2 is in first number max. And 11 is only in the third number. It has power 1 only. So as it is. So 2 raised to 4 into 3 cube into 5 raised to 3 into 7 square into 11. We have in the LCM. Is it clear? It is, even though it is not asked, we can practice. No. Is it clear? Okay. So that was 9th question. 10th one. No. A is the answer. Okay, we'll discuss. See, find the LCM of given expression. First one is 4 into 27 into 3 into 5. So let me tell you. Listen, 4 into 27 into 3125 needs to be expressed in exponential form. 2 square into 3 cube into 5 raised to 5. Is it clear? So let me tell you, as being UPSC aspirant, you should know these. That 3125 is divisible by 5, and that's why 5 raised to 5. So up to at least to 5, you should have 1 raised to, means 1 raised to any number is 1 itself. 2 raised to 1, 2 raised to 2, 2 raised to 3, up to 2 raised to 5, like that. 3 raised to 5, up to 4 raised to 5, and 5 raised to 5. You should know. Okay. So 4 into 27 into 3125, this one is. Now 8 into 9 into 25 into 7 is 2 cube into 3 square into 5 square into 7. And the third one is 16 into 81 into 5 into 11 into 49. So we have 16 is 2 raised to 4. 81 is 3 raised to 4. 5 as it is. 11 is 11 raised to 1, that is 11 it is. 49 being 7 square. We can put 7 prior to 11. Doesn't matter. One and the same thing. Is it clear? As we are having putting those base in ascending order. That is the only thing. Okay. Is it clear? Now to find LCM, we have to take only common base in all. So in first number 2, 3, 5, in second number 2, 3, 5, 7, and in third number 2, 3, 5, 7, and 11. So common to all is 2, 3, and 5. That is only common to all 3. 2, 3, and 5 with their minimum powers. So 2's power is minimum 2 in first number. 3's power is minimum 2 in second number. In which number doesn't matter. It is minimum 2, right? And 5 has minimum power 1 in third. So 2 square into 3 square into 5. That gives you 180. Is it clear? Okay. Here I would like to tell you LCM. So regarding LCM, means even if it is not asked, we can put LCM. So the base in all given expressions, all base 2, 3, 5, 7, and 11 with their maximum powers we have to take. That so 2 raised to max 4 in third number. 3 raised to 4 max is again third number. 5 raised to 5 max in first number. 7 square in third number, and 11 is in third number only. So that is LCM. Is it clear? Okay. Now 11th question orally you can do. Orally. Here 2 cube into 3 cube into 5 into 11. Then 2 raised to 4 into 3 raised to 4 into 5 square into 7. And last 2 raised to 5 into 3 cube into 5 cube into 7 square into 11. As we have to find their LCM. So to find LCM, we have to take all base which are present here in this one. These are 5 base, all base with their maximum powers. So 2's power maximum is 5 in third number. 3's power is maximum 4 in second. 5's power maximum 3 in the third. 7's power is maximum 2 is again in the third. And 11 has power. 11 is present in first and third. Having both common power is 1 only. So that is reflected in which option? Option D is answer. Suppose you had been asked HCF in this one. What would have been your HCF? You just try to get. One zero, 1080. 36 into that. Here you can see on the board as I have given common to all, only common base to all. What are those? 2, 3, and 5. So 2 has minimum power. To find HCF, we have to get minimum powers. So 2's power is 3 minimum in first number. 3's power is minimum in first and third number, while 5's power is 1 in first number only. So 2 cube into 3 cube into 5. So to have fast calculations, we have to multiply as well as add to get nearest to tens like that. 2 cube is 8. 8 5s are 40. So 40 into 3 cube. 3 cube is 27. 27 4s are 108. And 0 there should be put. So it should have been 1080. Is it clear? Got this one? All right. Now, question related to this HCF and LCM of numbers in exponential form. This was a simple one, that is 11 till 9, 10, and 11 we saw 3. So in this we have, what is it? When we are finding HCF, we are taking common to all only the base. This we are taking common to all, and we are taking in LCM all base, right? Even if it is present in only one number, that is to be replaced in LCM. But for FCF, you should have base which are common in all. Okay, and for FCF, powers to be taken are minimum. For finding LCM, we have to take powers maximum. Is it clear? So because of that, your next question, 12th one, today's last question. I know this is a comparatively tough one, but try to get. Whose answer? Answer is okay. Okay. How do you get that one? Okay, good. Then HCF. So no. You found HCF of 3240 and 3600 only. By okay. Good. So option A and D are remaining. वो दोनों बचेंगे. After that. Okay. So how do you eliminate D? Option D. How do you eliminate that one? So why do we want the smallest? Absolutely, and answer is absolutely correct. I'm just checking which approach you are having there. Okay, no problem. You have done that 3240 and 3600, their powers in 2s, 3 and 4 like that. The same, absolutely correct. So you need to tell the same. Okay, no problem. Listen, first of all, meaning of this question. FCF, don't know please. FCF of 3240, 3600, and our third number is 36. So 36 is FCF of how many numbers? 3 numbers, of which we are given 2 numbers. Which are those? 3240, 3600, and a third number. That is what FCF is 36, and their LCM of again those 3 numbers only is given 2 raised to 4 into 3 raised to 5 into 5 square into 7 square, and we are asked to find the third number. Listen, long back this question was asked in Staff Selection Commission exam. This is a comparatively tough one because you need to do this one practically, even if it is explained in any book. Unless we get in that atmosphere, we are not understanding the same. Is it clear? So how to get that one? First of all, by procedure, I would like to give you. And as I said, this was asked in Staff Selection Commission exam. You can eliminate your remaining 3 options, and because of that, you can get the correct answer. So first of all, we'll do by eliminating. Okay. So how it is? We are given that the 2 numbers are 3240, 3600, and the third number, their HCF is 36 given, their LCM is given in exponential form, and to find the third number, we are given whatever the options that are again in exponential form. So everything is to be getting in exponential form. For that, first of all, we get FCF in exponential form. So FCF is 36, that is 2 square into 3 square. Are you getting me? Now LCM is 2 raised to 4 into 3 raised to 5 into 5 raised to 2 into 7 raised to 2. Now listen. We are going through options directly. So for that, whatever you know regarding this one, that FCF has base which are common in all, only common in all, and LCM has base which are all. Means LCM we are in LCM we have all base, at least in one of the numbers also, that is again taken in LCM. Now here being FCF 2 square into 3 square, so FCF has base 2 and 3. FCF has base 2 and 3. These happen because these are common in all. So common in all means in the required number also. So in required number we must get 2 and 3 as base. Are you getting me? 2 and 3. Is it clear? So 2 and 3 must be in 2 and 3 must be the base in required number. So option B and C are no more at the same time by eliminating these option B and C. Why? Because there is no 3 only in the base. By eliminating these, is it clear? 2 and 3, sorry, option B and C are no more, so that are cancelled. But after getting these one may get more frustrated because option A and D have 3 raised to 5 and 7 square is both common. So only it is the matter of 2 raised to 2 or 2 raised to 3. We have to decide whether it is 2 raised to 2 or 2 raised to 3. Now, to decide power of 2 in the required number, we will be helped by FCF and LCF. So 2's power in FCF is 2. and in LCM is 4. So nothing to do with 2 raised to 3 there. Are you getting me? 2 raised to 3 doesn't have any role in HCF and LCM, right? Because if 2 raised to 3 is the answer, if it had been 2 raised to 3, that means both these limits, 2 raised to 2 as well as 2 raised to 4, both have been already, we are getting. So in that case, in the third number, 2's power doesn't matter whether it is 2 raised to 2, 2 raised to 3 or 2 raised to 4. Are you getting me? Okay, so that's why option D will also be eliminated. Okay, right now we'll do in book how it would have been given. LCM is 36 2 square into 3 square. LCM is 2 raised to 4 into 3 raised to 5 into 5 square into 7 square. Now first number is 3240. Just a minute. 3240 is 2 raised to 3 into 3 raised to 4 into 5 it comes. If you have tried to get this one, it is like this. Now 3600 has factors 2 raised to 4 into 3 square into 5 square, and the third number let it be x. Third number let it be x. Now to decide this of x, first of all, common in all must be common in all in HCF. So they must be in third number. Are you getting me? 2 and 3 must be the base. Now in the third number, to have the third base or whatever the base are, in HCF the base are 2 and 3. In LCM base are 2, 3, 5 and 7. So the base which are in HCF must be in LCM. So can you tell me which are the base which are in LCM but not in HCF? 5 and 7. 5 and 7. Right? So from 5 and 7. In third number x, 5 cannot be there. 5 cannot be the base. Are you getting me? Why? Because if it had been in the third number, then it would have been common in all. So it should be reflected in HCF. So that's why 5 should not be the base in the third number. Is it clear? Okay. Now in the third number 7 must be the base. Why? Because even though in the first two numbers there is no base 7, then also it is in LCM. That means it must be present in at least one of the numbers. And being it is not in first and second number, it must be in the third number. Are you getting me? In the third number, base 7 has to be. If it had not been in the third number, then what is doing in LCM then? Are you getting it? Okay. So 7 has the base 7 has whatever is the power in LCM, that is we are taking from the third number only. So third number has 7 square. It must be. Now to decide, to fix the powers of 2 and 3 of the third number, we take help from HCF and LCM. In HCF, base 2 has power 2, and in LCM, base 2 has power 4. So minimum 2 must be there in any of the numbers, and maximum 4 should be there also in any of the number. So of which 2 raised to 4 we are getting in the second number. But the lower limit of the power of 2, that is 2 raised to 2, we are not getting in neither first number nor in second. That's why it has to be in the third number. So because of that, here it should be 2 square. Are you getting me? Is it clear? Okay, same is the thing. 3's power in HCF is the 2, and in LCM is 5, of which we are getting 3's power 2 in second number, but we are not, which is in LCM. So it has to be in the third number. So we get the third number is 2 raised to 2 into 3 raised to 5 into 7 square. Is it clear?